files. Okay. So I have 2 documents that I want to go through in the class, but based on the speed that I'm going all the time, probably we cannot go through everything. So I asked you which one you prefer. So I wrote a sample exam that I also gave my tutor to talk to students who go to tutoring to talk about it. So how many of you went to tutoring? I know 4 of you went, but probably most of. Okay. So one document is that I have for the class. So probably I just walk through or like go through it really quick, tell you what type of questions I'm going to ask you, and that can be, this that I'm going to show you now can be a study guide for you. So you know what type of questions you're going to see in the exam. The other one, I included your quiz 4 answers, and I'm going to include all the answers that I didn't upload on Canvas today, so you have them for your exam. So, and something that I should have mentioned earlier, but I'm going to mention now, is course evaluations. So I know usually we don't like to do evaluations, even if I go to a restaurant or whatever. If I receive, fill out the survey, probably I don't like to do it, I don't have time. But in this class, and especially for instructors, course evaluations is the way for me to have my job. So if I receive good evaluations, it's good for me. If I receive bad evaluations, it's not super good for me. So, I care about my students, and I don't think overall I need to worry about my position at university, because I think I'm doing my job as best as I can, and I try my best to improve every day. That being said, I asked you to fill out the course evaluations so I can improve as I go along with my career, my teaching style. So if you saw something that you liked, mention. If you saw something that you think can be improved or you didn't like, also mention that. So I want to know how to do my job better. For instance, last semester, I had homeworks as extra credits, and some students told me it wasn't fair for them they had only 4 exams and 4 quizzes. Most of their grades were exams. So I realized that wasn't fair towards the students. So what I did, I included more homeworks, so you don't only rely on exams. Usually students do worse on exams. They do better on take-home exams or open book, open notes. Anyway, all those things being said, if you saw something in the class that you liked, please write it. And if you saw something that you think can be improved or you didn't like, also write it, so I can improve my teaching. And also, if you saw something that you liked, and if my department chair sees that there are things that the students really like, maybe they encourage other professors to do them too. So that's good for us to have a good communication. And do it sometime that you have time. Just don't answer everything A or everything B to be done with it. Just do it when you have time. And also make sure to, if the, which one is a strongly agree, which one is a strongly disagree. Sometimes the students want to write a good evaluation, and it happened to my colleagues that the comments were all positive, but the evaluation was really bad. So it showed that the student wanted to select the strongly agree, but the strongly agree was on D. Do you know what I mean? So yeah, I guess enough with that. And I'm going to keep repeating student evaluations until we have time to do them. Okay, so this is something, and I also included this in the previous, not last one, the one before slides. Can you see those? Is it visible? Okay, so one question that I'm going to ask you, or 3 or 4 questions on exam on Friday, would be naming compounds. And I asked you 1 or more, at least 1 for alcohols, 1 or more for mercaptans or thiols, right? And then 1 or more for like benzene rings, right? When you had like phenol or aniline. And for benzene, I'm going to give you that table that had different structures, like what was aniline, what was, nitro, benzene, what was toluene, right? So you don't have to worry about those. But phenol, you should know, okay? So I have some sample questions here, and I guess the most efficient way for me would be to just ask you to look at them real quick, and I name them, and then you tell me. I guess they have all already named. So this is A, B, C, D, E, F, and then G, H. And then tell me which one you want me to explain. I think that would be the fastest way. Any question about any of this? Everything's good? Any questions? Are we good with naming this one?
Can you go over C?
Okay, yes. Great. Yeah. When the students don't say anything, I'm thinking, do they know or they don't care? Or they're just waiting for the class to finish? Okay. So when you see these structures, when you see OH, what you do, you start naming the carbons where it's closest to the OH group. And as always, we look for a main chain, right, for carbon. So you have like here, 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 carbon. And probably I changed the color so you can see better, right? And previously, before I taught alcohols and thiols and all this good stuff, I told you we care about double bond more. So we name carbons that we encounter double bond or multiple bond in general soonest. In this case, we name the carbons where it's closest to OH, right? So here, this would be 1, 2, 3, 4, 5. Okay, and you see, this one, you should know that when we have one carbon, the base name is METH, so like methane, ethane, right? Propane. Some of you confuse propane with pentane. Go back to the table, make sure that you know all these things. So now when we have 5 carbons, the base name is, pent, I guess. If it was an alkane, it was pentane. If it was like alkene, pentene. And if we had triple bond that we do here, we added YNE. Remember that it rhymed with wine, so we call that pentyne. Good? Now, when we have OH, we add OL at the end of the compound's name, right? Like methanol, ethanol, propanol, right? So here we add OL, and what is the carbon number that is attached to this OH? 1. That's why we write here 1. Hopefully you can see that. And what about the triple bond? What is the carbon number that is attached to? 3. Why didn't I say 4? Isn't this one attached to?
It's the one that's closest.
Exactly, the one that is closest, the one that you encounter sooner. There are like 2 carbons involved in the multiple bond, right? We name the one, we write the one here that is closest, that has the lowest number. I guess that's the best way to put it. So we call that 3-penty-1-ol. So in your exam, I may give you the exactly same thing, or here I have like double bond. So if it's double bond, how this name would change? Here would be ENE, exactly, pentene. Any question about that? Yes?
So comparing to D, why would D not be 2-chloral ethyl 1-ol instead of 1-ethanol? Does that make sense?
Okay, let me see. Oh, so
like so for C, the 1 is in between the pentyne and the ol.
Okay.
Why isn't it that for D?
So how should I write it? Just tell me to write and then we discuss.
2-chloro. Okay, maybe not.
Yeah, I mean, if you can write it some other way that it makes sense, that is fine,
Okay.
you know. But these are like the most straightforward way of writing things.
Okay.
But as I said, if you Google these compounds, you know, and go to different websites that they have these chemicals, like ACS website or any other website, you see like a list of names that they can be applied. So if you can write it some other way, as long as the rules that we studied applies, or like it has like, you know, that is like alcohol, it has OL and so on, it would be correct. And in your exam, I don't give something confusing that, I don't know, kind of like, as your friends say, kind of like have this FETH and then one all, or I don't give something that confusing, so you don't have to worry about it. As long as you can write the name, you will be good. Any other question about this slide? Yes?
For A, is there like another option that you can do? Like, because when I did it, I just came up with 3 bromo, 1 propanol. Like, is that another option or is that incorrect?
So what is the other option? Let me write it.
I did 3 bromo, 1 propanol.
Bromo, 1 propanol. It went to my carpet. Propanol. Okay, so let me see. So 1, 2, 3. So we say 3 bromo, and then 1 propanol. So you can also write it like that. So in this case, because of the location, so here if I call this 3 bromo, and automatically it means that the location of this OH, this is like the first carbon is attached to OH. But if you like it like this, is also correct. Yeah, it doesn't make it wrong. Great question. Any other questions? Are we good with this one? I'm going to give you this in the exam. I'm just emphasizing on that a lot. So remember, phenyl and benzyl. Can anyone tell me what was the difference between phenyl and benzyl? Exactly, benzyl is attached to, you know, here, if you have, you know, a benzene ring that you eliminate 1 hydrogen and then you attach this. So this is phenyl, right? You just eliminated hydrogen. And then if you have CH2 here and that attaches to something else, that would be benzyl, right? Benzyl. So here, in this case, we have like all propanol, so we know that we have a OH. So propane, because it's AN, it means that it has a single bond, right? It's like something else. So it's difficult to say propanol, so that's why we do the thing that we do here, right? Just linguistically. But as I said, I'm not going to give you both, so don't worry about that. And then here we have like 3 carbon in the main chain, and then phenyl is like this structure, and then carbon number 2, we have a phenyl attached. So you write propanol, so you have like 3 carbons. Remember, propo is like 3, pent is 5. And then carbon number 1 is attached to OH, and then carbon number 2 is attached to phenyl, and this is phenyl. And then this is, I guess, the rest of our structure. Good? So I give you like similar things. Here I just give benzyl. So, good? Okay. If no questions, let me go to this slide. Okay. Can you also look at this real quick while I name these things? Yes, I call this A, B, C, D, E, F, G, H, I. Okay. So one type of question that I ask you, I give you an alcohol, I say what type it is. Yes? What's that? Oh. Oh, the colors? Okay, okay. Thank you for mentioning that. Okay, that doesn't help. What about this color? Is this? No. Oh, okay. Let me, is this better? Okay. Okay, so here, is it clear how we name alcohols primary, secondary, tertiary? So the carbon that is attached to OH, you will consider that one, right? And then see how many other carbons it's attached to. So here, the carbon that is attached to OH is only attached to one other carbon, right? So we call that primary, okay? Or, you know, this one here, right? The carbon that is attached to OH is attached only to one carbon, so it would be primary. Or like this structure here, let me go a little down here. Okay. So this carbon, right, that is attached to OH is attached to 3 other carbons. So it would be tertiary. Are we good with this type of questions? Good. Any questions? So now, I didn't have enough time to crop the photo, but hopefully you can see well. Can you? Is it good? Okay. So one question that I give you, and I really encourage you to save time. I didn't write multiple choice questions, but it gives you the spirit of what I'm going to ask you. I encourage you, like your extra credit homeworks and quizzes, just cover the answer and answer the question yourself and compare with the answer to make sure that you know how to do these questions. So one question that I'm going to ask you in your exam, and if you know the answer to all the extra credits that I asked you, and also all the homeworks and quizzes that I'm going to post, the solutions, and also everything that I'm talking about in the class today, all the materials that I give you, you should do really well on your exam, no doubt. So here I said draw the structure for M-nitrotoluene. Okay, so this is toluene, right? And then when we want to write M-meta, we said that if this substituent is here, what would we call that? Ortho, right? Remember, close ortho. If it was here, what was that? Para, exactly. Kind of like I told you, like kind of parallel. So here we have meta. And nitro is NO2. As I said, I'm going to give you those benzene rings and the names. Which one is cumin, which one is toluene, which one is phenol. So you don't have to worry about them. But you should be able to use them. Or here for chloroaniline. Again, this NH2 makes it aniline. And then when the base name is aniline, you start counting from this carbon. 1, 2, 3, 4. And number 4, we have chloro. Good? So this is another type of question that you're going to see. And also definitions. Just make sure to know all the definitions. I'm going to ask few questions. What is this? What is that? And as long as you read the lectures, you can easily answer them. So I'm not going to spend time on them. And then I tell you, name this structure. Again, remember that this is benzyl, this is phenol. And this can get confusing because the molecule is big. Anytime that you're intimidated by the structure, just substitute, for instance, this benzyl with a Cl, okay? So if this was Cl, and if you had this structure, what was the name? It's really similar to what we talked about here or here. So what is this?
Orthochloro-phenol.
Exactly. Okay, now your Cl is substituted with benzyl. So instead of chloro, we write benzyl. Is that clear to everyone? Questions? Yes.
So the benzene structures, like are we gonna need to memorize like toluene and like aniline and stuff like that?
That one I give you in the exam.
Okay.
Yeah, that's the thing I told you that don't worry about it. Those, you had like 8 structures or so that they were like, this is cumin, this is aniline, this is toluene. So toluene and phenol, we solved so many examples, so probably you know, but I'm going to give you that. So don't worry about it. As long as you know how to use them, you'll be all good. Questions? Okay. The next question that I'm going to ask you is these reactions. Remember that you had like sulfonation, you have nitration, different types of reactions that you had. Go to the slide, make sure you know all these types of reaction. And I say, what is the product of the following reaction? Or I ask you to complete it, you should be able to write it and know the name of the reaction. Okay? Questions about how we write this? Good. And then naming compounds. Since I spent so much time talking about isobutyl, sec-butyl, terts-butyl, N-butyl, I'm going to ask that in the exam. Okay, make sure to know how to name these alkyls and then name these alcohols. Any question about this question? Can everyone name this compound without difficulty? So again, you start counting carbons where it's closest to the OH, right? 1, 2, 3. And remember, we choose the longest chain, but even if you go this way, it would be the same result, so it doesn't matter. And then you have one methyl outside, and then you also have alcohol, so you name it like you add OL, right? You have 3 carbons in main chain, so you write propanol, right? And carbon number 1 is attached to OH, carbon number 2 is attached to methyl. So you call that 2-methyl-1-propanol. Okay, or if you remember that this structure here is isobutyl, right? So we call that isobutyl alcohol, and you should know both names. Good? Questions? Okay, naming this compound, now it should be, so remember, if you have benzene ring attached to CH2, that is benzyl. You can call that benzyl alcohol, or you can call this, phenyl methanol. What was methanol? Right? It's a methane that instead of 1, we eliminate 1 hydrogen, we add OH. So that would be methanol. So if we substitute one of the hydrogens with phenyl, we can call that phenyl methanol. So, really study well these questions. I ask really similar questions. So I say, I give you this structure, and I say, is the following name correct or false? Benzyl methanol. Is it? It's not benzyl methanol, right? Or if I say phenyl ethanol. So as long as you know this, well, you can answer alternative questions from this too. Okay. And then, what kind of alcohol 2-butanol is? So you write this structure, and then based on this structure, what type it is? Secondary, because the carbon that is attached to OH is attached to 2 other carbons. Questions? Okay. The other type of question that I'm going to ask you is this. Remember that we said that hydrogenation is an exothermic reaction, right? And I told you that if we have a certain amount of energy associated with breaking 1 double bond, if we have 2 double bonds, we multiply that number by 2. If you have 3 double bonds, we multiply that by 3. And then we wanted to prove that benzene doesn't have double bonds, it has something intermediate. We compared the amount of energy that theoretically would have been for benzene, which is 3 multiplied by energy required or energy released to break 1 double bond, multiplied by that by 3, and then we saw that the energy to break benzene is not that, right? It was less negative. Remember? when we talk about this lecture. So I can give you this. I say hydrogenation of cyclohexene releases this much of energy. Based on this information, estimate the resonance energy of benzene, knowing hydrogenation energy of benzene is minus 50, almost, kilocalorie per mole. So what you do, if benzene had 3 double bonds, we would multiply this number by 3, right? And then it would be around 86 kilocalorie per mole. But we know that benzene doesn't have double bonds. Remember, it was intermediate, something between single bond and double bond. So we deduct this energy from this minus 49, deduct these two, and it would be 36 kilocalorie per mole. Anyone remembers what was this energy? What did we call that? What's that? Here, right? Stabilization energy or resonance energy. I may give you this in exam and I say this value here, what does that correspond to? Okay. Remember? Mm-hmm. Or I may give you the energy required to, the energy that is released for breaking one double bond, and then give you an alkadine, right? And then I say, what would that energy be? So you should just multiply the number by 2. Or if I have 3 double bonds, multiply by that by 3. But for benzene, you know, don't do that. Unless I give you the hypothetical structure, right? Remember? And I ask you the hypothetical structure that if we had like, you know. So if you want to name, if, you know, this structure, if benzene had 3 double bonds, and then we wanted to name it based on how we learned before, what would that be? Can anyone tell me? So we say, for instance, 1, where am I? Yeah, I guess I go the other direction. 1, 2, 3, 4, 5, 6. So I say 1, 3, 5, cyclo, right? And then how many carbons do I have? Hexa. How many double bonds I have? In. So this is like, so this is the hypothetical, the most the stable hypothetical structure, you know, one of the resonance structures of benzene. Remember? And we have 2 resonance structures. So if I ask you what would be the energy of this hypothetical structure, you just multiply this number by 3. Does that make sense? But benzene is not this. Benzene is not that, because it doesn't have double bond. Good? Okay. And again, you know, this type of reactions to write, I have another one to emphasize that I'm going to tell you what is the product of these reactions, and then if you study these, you can easily answer them.
Hey, Lita.
Yes.
So for the actual product, why would it not be CH2 as a substituent instead of the CH3? Because, so,
here,
I guess the real question is, where did the hydrogen come from for the HCl? That's, I guess, my real question.
So if you write the, here, you have CH, right?
Oh, yeah, okay.
Okay.
Yeah. I
Good?
get it now.
That's just a substitution reaction.
Exactly. And remember, the reactions of benzene, it wasn't addition, it was substitution because they didn't have double bonds. Great questions. Any other questions? Are we good with these? Okay. Now let me focus this image. Okay, now these boiling point type questions. So when you want to see which compound has the highest boiling point, based on what we studied during the past sessions, what do you care about? Or how do you answer this? If I ask you the exact same question, how do you say which one has higher boiling point or lower?
Like it has an OH.
Exactly. If you have OH or if you have hydrogen bonding, the boiling point would be higher. If all of your compounds have hydrogen bonding, how would you decide then? Longest chain, exactly. The one that has more carbons, it's heavier, so boiling point would be higher. So among these, I also wrote the structures here, and I may just give you the names, not the structures. So you should be able to write them. So between these three, I guess between dimethyl ether and propane and these two, we know that these two, ethanol and 1-propanol, would be having higher boiling points because they have the same relative number of carbons, among those. But between ethanol and propanol, because propanol has more carbons, it would be heavier, so it would be having higher boiling point. Any question about that? Good? And then I can tell you which one has lower boiling point. So similar type questions. And I also wrote here the explanation. I encourage you to study that. I may ask true or false questions from the explanations that I wrote. So as long as you read them. So here, Bronsted-Lowry and Lewis acids and bases. Can anyone tell me what was Bronsted-Lowry acid? Proton donor, right? And I always tell the students, remember, HCl is a strong acid. And it should be a strong acid with all the definitions, right? So HCl is a strong acid. What does it have? It has a hydrogen ion, or it has proton, right, when it dissociates in water. So it can donate this proton. So proton donor. Okay, so this would be Bronsted-Lowry acid. So if something wants to donate proton, and proton has positive charge, right? It's equivalent to accepting electrons. Does that make sense to everyone? So if something wants to accept electrons, that is also an acid, but it would be Lewis acid. In Lewis acids and bases, we deal with electrons, but in Bronsted-Lowry definition, we talk about protons. So if you learn this one, the base would be opposite. Base would be proton acceptor or donates electrons. You can also, just the same thing that I did here, write it in your exam before answering questions for acids and bases, and then answer questions. So here, I said which one is an acid, BF3 or F minus. So when you write this structure, BF3 plus F minus, so it has, F has negative charge. So do you think, and then here you also have like BF3, and then here I also gave you the equation. So you see what happened, that you have BF3, and now your structure, if you just look at BF3, right? Previously it didn't have any charge, and now it has negative charge, right? So what did happen? BF3 accepted electrons, right? So for that matter, because it accepted electrons, it's an acid. So if one of your species, one of the reactants here, one of them is an acid, the other one would be a base, because one gives electron to the other, right? So if this one is electron acceptor, this one is electron donor. Question?
Yes.
Yes.
So why would you go for Lewis acid? Wow, that was not a word. Lewis acid instead of the Bronsted-Lowry acid.
So here we don't see hydrogen, so it's not convenient for us to talk about donating protons, because for donation of protons or accepting protons, we should have hydrogen. So since we don't have it, it's not convenient to talk about that. But if you have a structure, for instance, HCl, that you can think about both ways of answering questions, both should give you the same answer.
Okay.
Great question. Any other questions? Good. Okay, so this is another type of question that you see, and you saw that in your extra credit homeworks and quizzes, and I cannot emphasize enough, study your extra credits, questions a lot. You're going to see similar questions. It would suck if you see that all the questions that you see in exam I already talked about in the class, or you had before and you answered them wrong. So make sure to do them well. And here, okay, again, read the definitions well. I'm going to pass through these real quick. So definitions, this is just like I changed the definition here to make the statement false. Make sure to read them well. About Ka and pKa. Ka higher means stronger acid or weaker acid. Which one? How many say stronger? How many say weaker? Okay, so I'm glad that I cut this. So Ka higher means that your acid dissociates more in water. So it has more ability to donate protons, so it's a stronger acid. So Ka higher is a stronger acid, and pKa is reverse of Ka. So pKa higher would be weaker acid. Okay, and for more explanation, just go to the lectures, review them again. But if I give you like some numbers, I say which one is a stronger acid. Ka higher would be a stronger acid because the acid dissociates more in water. But pKa is minus logarithm of Ka, so it has like reverse relation. Okay? And this is R. I didn't do a good job writing this. Good? So here you look at these values. So for pKa, again, so if it's higher, it's weaker acid. So you look at these numbers, 15, 10, 0.25. Which one is higher for water, right? So that one would be weaker. Make sure to know this. You're going to see 1 or 2 questions regarding that. And here, again, you have ROH plus H plus gives ROH2 plus. And then I tell you what is alcohol here. Is it acid or base here? Exactly, it accepted proton, right? So for that matter, it would be a base. Questions? Good? So here. So when we have SH, what is the category of the compound? Thiol. Exactly, or mercaptan. You should know both names. So here you have a phenyl that is attached to mercaptan, or rather a mercaptan SH that is attached to phenyl, or you can call this thiophenol. So usually we have like thiol at the end of the name, but for phenol we can just say thiophenol and we drop the L. And as I told you, I'm not going to give you phenol thiol in the exam and then ask you to choose between them. That is technically correct too, so don't worry about that. And then here again, we talked about this a lot in the class. This is isobutyl, this is mercaptan, this is the name, okay? Or diethyl ether. Remember that ether is oxygen that is attached to 2 other groups here, like this is ether, right? And then you have diethyl, meaning that 2 ethyls. So this is like the way to write this structure. Questions? And then finally name this compound. This is exactly the example that we talked about in the class. So write the expanded structural formula. And remember, if you have oxygen attached to alkyl, we call that alkoxy. Okay, so this would be ethoxy, and this is your methyl that I dropped an L accidentally. So you name the carbons somehow that you reach the, this ethoxy sooner, and then you call that 2-ethoxy, 3-methyl butane, because we have your 4 carbons in your main chain. Question? So you're going to see 1 or 2 questions naming ethers, or I give you the structure naming them. So similar to these 2 here. And also boiling points, hydrogen bonding, and all that, comparing ethers and alcohols, you should be able to compare them. Okay, so remember, what type of interactions, intermolecular forces ethers have? What's that? So we have dipole for ethers, right? Because the oxygen is not attached to hydrogen, is attached to carbons. Remember? Yes. So van der Waals is the same as London dispersion. Okay? I mean, different books say slightly different things, but in your book, van der Waals and London dispersion are equivalent, or like they consider them equivalent, and those are for like alkanes or like in general non-polar species. And this is also controversy between ethers, that are they, because they have like the geometry is symmetrical, and some books say that is non-polar, but some books they say that it's polar. For the purpose of our course, we just consider them dipole, you know. But I'm not going to ask, you know, specific questions about that. As long as you know which one has higher boiling point, you know, and which one lower, and compare them with alcohols, you should be good. Great question. Any other questions? Good. Okay. So this was that. Now I'm going to go to your quiz real quick. Insert. Go to first slide. And I'm still recording. Okay. So I have like the quiz statistics and all that too. So the average was really good for the quiz. So I'm not. When I converted that to PDF. That's why most of the time I take screenshots, but it takes much more time because I like to see the whole green thing, you know, compared to, I mean, you see here that too. Okay, so can you, I guess I just walk or like go through the questions and then just, you know, ask me if you have any questions. So the structure of chlorobenzene, is this clear? Why this is this, oh, not this, that one, sorry. Why that is, where is it? This one. Remember, when I tell you benzene, you should have a benzene ring. You know, I was being tricked myself too. So that is, you know, cyclohexane, right? You should have a benzene ring. Okay, here represents phenol. And what was phenol? See? This is phenol, right? We have OH attached. And then this structure here, when you have OCH3 attached, what do we call that? We had like OCH3 attached to a benzene ring. Anisole. As I said, I'm going to give you these in the exam, so you don't have to worry about remembering the name of these. Okay, so let me just pass through this. Just ask me if you have any questions. Otherwise, I just go to the questions that most students had difficulty with.
Ooh, yes, this one.
Okay, this one?
Oh, no, I'm sorry, the lower one.
Okay, this one?
Yeah.
Which of the following names represents more than one compound? Okay, so dichlorobenzene. So this is benzene, right? Dichloro, so what is the name of this one? Exactly, you're right. Ortho, right? Dichlorobenzene. What if I put what about this structure? Meta dichlorobenzene, right? What about this one? Para, right? So that's why this compound represents more than one. It's not only one. Good? Okay. What about this one? How do you name this? So again, you know, don't be intimidated by the, can you see well or should I zoom? Maybe zoom a little. So don't get intimidated by the structure. You can just, if you remember that I told you in the class several times that if you have a benzene ring attached to CH2, that is benzyl, right? So this is benzyl, and you can just simply substitute it with one Cl. If it was Cl, what would you say? It's ortho chloro or like bromochlorobenzene, right? We just write them alphabetically. But now instead of Cl, you have benzyl. So you write orthobenzyl bromobenzene. And then here between these two, we just go alphabetically. Good? Questions? Okay, let me zoom out again. Okay. Which alkyl benzene, C9H12, when nitrated can yield only one mononitro product? Let me go back to the question again. Which one of the structures that we had, when nitrated, can yield only one mononitro product? Okay, what about this one? Any thoughts? Mono nitro product.
It's going to be C.
Mhm.
Because it'll, in each one, like, there's 3 that you could put one on.
Uh-huh.
But they'd all be, like, identical, basically, because it's a symmetrical.
Exactly. Can everyone see that? Questions? Are we good? So for the other ones, as your friend mentioned, when you put the nitro, you can have multiple structures. But for this one, anywhere that you put the nitro and then you name the compound would be equivalent. Okay? Good? Okay, let me go quickly to these ones because we're running out of time. Any question? So let me just pass through this. And I'm going to post the solutions to this. I guess at this point I'm running out of time. So I'm going to print them, write the solutions on these, and upload them on Canvas along with all your other homework solutions. So what I'm going to do, I'm going to go to the quiz statistics, the questions that most of you had issues or problems. I'm going to give you those in the exam. So make sure to study them well. And I will upload all the solutions today so you have them for the exam, and make sure to study the questions that I talked about in the class really well. You're going to see really similar questions. Okay, so if you know the answer to those questions, you should do really well on the exam. Yes? Yes, I'm going to post that, yes. Yeah. I'm going to post that, and then when I post that, the deadline would be on Sunday, but I posted today as well. Yeah, I was just grading extra credits for my 101 class. It just took forever to update their grades, but I'll do that today.
That is fair.